Welcome to this DC Python event. We will be going to our speaker in a few moments, but firstly, this event is only possible because we've had the gracious help of two wonderful sponsors. So firstly, I will introduce Sarah from Hatch IT.
Hi guys, welcome to the meetup. Thanks for coming. My name is Sarah Sewell from Hatch IT. If you haven't heard of us before, we are a community-driven technology consulting company, and we specialize really in working and partnering with early to mid-stage startups in the DC metro area to help them with strategy and also with growth and scaling out their engineering teams. So we love, partnering with DC Python to really just stay in touch with the community here. So thanks again for coming and come chat with us if you have any questions. Thank you. Hand it off to Molly from Flat Iron. Hey everybody, I'm Molly. I'm from Flatiron School. If you don't know who we are a data science and software engineering bootcamp here in DC, and our campus is actually located in this building. I think we have some data science students here. Raise your hand. Awesome. So right now we're offering a data science fellowship, which is $0 tuition for the student. And we just require you to have a master's degree or a PhD. And if you have that, then you qualify for the program. It's 3 months long, it's in this building, and you learn Python and R, which some of you probably already know Python. But if you have any questions about that program or our software engineering program, you can come find me at the table in the back. But thanks for coming.
Okay, so I will now pass it over to our speaker, who will be talking about pandas and some fairly interesting examples.
How's everyone doing? So by a show of hands, how many people use pandas regularly in their work? And how many people use Jupyter notebooks regular in their work? Okay, that's a much. How many people use Altair ever? Okay. So it is a data science talk, although a very light one, since we're going to be focusing on things like data wrangling and data munging more than we are on things like modeling and machine learning. So very beginner friendly. Since it is a data science talk, these are some opinions about what data science is. I like the last definition, data science is statistics on a Mac. Has anyone have a better definition than that? No? Okay, we're going to go with data science is statistics on a Mac. This is an interesting diagram that Jake Vanderplas, who is a Python visualization guru, often uses, which is his definition of data science. It's a combination of substantive expertise, hacking skills, and math and stats knowledge. Since I don't have math and stats knowledge, this is going to be a danger zone presentation. So people are going to have to bear with that. Just to motivate some of the things that we're going to be learning, we're going to be using a local example, some local data. So the Stanford Open Policing Project collected, I think, over 200 million traffic stops across the United States. About 50,000 Americans are stopped by police every day. It's the most common form of interaction that civilians have with their local police department or with their state police department. And yet there is very little research and very little study on that just because it's not centrally collected. You may have heard of the Uniform Crime Reports the FBI puts together that is for more serious crimes, for arrests, for felonies, and that gets reported by city governments and state governments over to the FBI. This does not. So you need academics to gather this data and figure things out. I think it's an interesting example, not only because, for example, today there's a district attorney's race primary in Queens, New York. There was a big movement for electing reform DAs in Virginia earlier this year. So it's a live political issue. It also serves some good examples of how difficult it is to work with real world data rather than data that you would just get off of Kaggle. How many people have used Kaggle? So Kaggle is wonderful because everything is right there for you. there's no nans, there's very few nulls, there's very few little garbage. You get to do real work right away. You don't get to do real work right away when you work with real world data. And people are going to have to bear with me as I go through the notebook.
Sorry, did you introduce yourself?
I'm Ilya, and I'm going to keep introductions to a minimum just because I want to get through as much of this as possible, and then I will be around to talk afterwards for as much as possible. So the number one reason why people use pandas, in my opinion, is this one function, which is pd.readCSV. I would say it is 80% of the reason why people use pandas. And the reason why that is because it will take almost any garbage you give it and turn it into a data frame. If you're familiar with R, you know what a data frame is? Pandas introduces the data frame concept to the Python ecosystem. There are equivalents to read CSV for other file formats. So there is read JSON, there is even read HTML, which will find an HTML table if there is a well-formatted HTML table on the website URL that you give it. It will turn it into a data frame. Something that has everyone who uses pandas in their daily work heard of every single one of these D types? Is there any D type they have not seen before? I would say category is the one that is least likely to be known just because it does not come from NumPy. So you may know that NumPy forms the basis for pandas. And most of the data types come from NumPy. So you have floats, you have integers, you have objects which represent strings and anything else. You have bools, of course. Categorical data are things like race and sex. It is a good idea to use things like categorical data. For one thing, it saves memory because when something is an object, it carries a lot of other attributes with it in the Python world. When it's a category, you can reduce the amount of RAM that you're using. You can also do things like ranking. So if you have a Likert scale, that is, if you're doing some kind of social research and you have a data frame that has answers like agree very strongly, agree somewhat strongly, disagree slightly, then you want to be able to rank those things. Obviously, race and sex, we do not rank those categories, but there are data types where it's very useful to use categories. For those who use Jupyter notebooks regularly, are you familiar with magic methods? That is the little percent signs and the question marks. Yes, no? Yes, okay, good. For those of you who are not, that is also a very good reason to use Jupyter notebooks. You don't know what a command does, you put a question mark after it. It tells you what the command does. It gives you this very long function header and description. In addition to time it, there's a whole bunch of other, bless you, commands that you want to use. So the first thing you generally do when you have a data set is just take a look at the shape of it, take a look at what you have. Here we have these, a huge number of rows, 840,000. So I would say we're getting into the realm of largest data, big boy data. Not exactly big data, but like large adult son data is how I would characterize it. Does anyone want to tell me why it says object instead of something more specific like string? Someone raise their hand. No? By the way, can everyone see? Fine. Do I need to zoom in any further? No. All right, so it says object because Python pandas holds a reference to the memory location of the string rather than the string itself. It's just this weird quirk that that pandas does, and I think it confuses people because they keep converting something to a string. They do it 3 different ways. They expect to see str, they expect to see varchar or something like that as they would in a database, and they never see it. One command you might not be familiar with is .info. One nice thing about it is that it tells you the number of things that you have and also the categories at the same time. And of course, one of the first things you do with any kind of data set is you look at the head, you see what you have. So here we have these 800,000 police stops from a select number of police departments in the state of Maryland. Each individual row represents one police stop. So this is one instance of a person getting pulled over and either getting searched, not getting searched, being arrested, not being arrested, being cited for something or not being cited for something. One thing you often want to do is reset the index in a data frame because this raw row number that we got from the Stanford Open Police Project, it already serves as a good, unique index. You don't need necessarily to have a new one created for you, but because we didn't set an index on import, we should set an index now, although you do not have to. So is anyone following along, or we see a few people are. One question I have is what the first driver was cited for. And my only point here is that this is a use for subject matter expertise because I have no idea what 21-202 is. But if we look it up, it is apparently they ran a red light. That's what traffic lights with steady indication tells me that they did. But of course, if this was a more complicated data set, you could tell where subject matter expertise really comes in handy. And here I just want to go very quickly through some of the notation in Pandas before we get to something more heavy-handed. You can select columns in different ways. You can select them through dictionary notation, that is the brackets, or you can select them through object notation, which is the dot, and either one works. So here we have the Maryland subject sex.head. It gives me the first 5 sex identifications for the first 5 people that were pulled over. If I run the next slide, we get a similar thing for the outcome, except here we are using the dictionary notation. Anyone want to, who uses Pandas, give an example of where it matters which one you use? No one knows where it matters?
If there's a space.
So if there's a space is a very good example. If there's a space, then the dictionary notation like this works. Of course, the object notation of just putting a period is never going to work in that case. You can select multiple columns, and we can do all sorts of indexing. So with the docloc command, you select the indexes of the rows that you're interested in. So in this case, the numbers aren't particularly relevant, so it's hard to know what you're looking at. But in some cases, the index is something actually meaningful, and if you want to select something out, you would use loc. You would use iloc if all you care about is the location that does not refer to any particular index. That is, in this case, you're taking the 41st hundred through the 4,150th row, whatever its index happens to be. And you can see that the same kind of string slicing notation that you're used to in regular run-of-the-mill Python still works here. It's very powerful. Is this what you do in R as well? I don't use R. I don't. Yes, no?
In R, you would use verbs,
Okay.
dplyr verbs. You would do filter to select rows and select to get columns.
Okay. I'm going to be coming back to you whenever I need confirmation on how R works. So here again is another example of just using that kind of string slicing notation, index slicing notation that you're used to in Python. You are never done with cleaning data once you get started. It takes up about 80% of the time anytime you work on any kind of the project, and that is just a fact of life. So one thing that we always have to worry about is nulls in the data set, and it's nice when the null is just an AN rather than some kind of garbage value like a question mark. I do want someone to answer this question. How come this works? How come if I select Maryland, which is the name of the data frame that I have, and then I add a method to it, is null, which returns another data frame that has trues and falses in it for whether something is null or not. And then I method chain, which is a way of saying add another method sum to it, that I get these numbers back. Like what is the reason for why that can possibly work? How can you sum up a data frame of true and false? What is the reason why that works?
It's because false is equal to 0 and true is equal to 1.
He said it's because false is equal to 0 and true is equal to 1. And that's exactly the answer. And people are going to have to interrupt me with questions because I might not be looking up. So just yell.
Just another
Yeah.
On a previous note, is there an easy way to set any column to be the index? Like if I want to change the index of a data of
Yeah, I think we did set it up here, did we not?
That's right there.
Yeah. We did. And the only thing that verify integrity true does is make sure that it's a unique index, because by default it does not have to be a unique index. You can have multi-column indexing and they can be whatever, but you will regret it if it is you do not do verify integrity. Good question. Yeah.
So this is all being done in memory. If you had a larger data set,
You would cry. There's lots of packages that deal with that. I think the most popular one is Dask in Python. Mostly it's used for computer clusters, so if you have multiple machines. However, I believe you can use Dask on a single machine, and all it will do is just take it from disk to memory in pieces, perform some operations, send it back to disk, and you'll be off. Rami?
that will let you use all cores.
And it will let you use all cores on your computer, which I did not know. So one question you want to ask yourself whenever you're looking at a data set is, do the nulls really matter to the question that you have at hand? So for example, here for reason for search, we have a huge number of nulls, but it seems like it's only null when a search has not been conducted. Because of course, if a search has not been conducted, then we don't care whether there was a reason for the search. If a search has been conducted, then we care if there's a reason. If there's a lot of nulls for a reason when a search has been conducted, then we have some bad data and we have to deal with that. Otherwise, we don't really care. Yeah.
Then you can use the null to your advantage, right? You just subtract the number of cases and then get.
Yeah, absolutely. He said to use the null to your advantage and subtract the number of cases where that's the case. So in this case, it looks like reason for search is only null 56 times when a search has been conducted. And perhaps if you're a data journalist, you care about that, where those are 56 instances where police conducted a search, but on the ticket, on the after action report, they didn't say why. Most likely it's because police reports are homework for cops, and cops are not so good with their homework. And it is not anything other than a bookkeeping error, but perhaps it isn't.
Well, in their defense, if it's 56 out of however many
Absolutely.
thousands,
Yeah, absolutely.
That's probably not bad.
And you know,
That's
like,
amazing.
It seems like the Maryland police departments that reported here do both a good job of record keeping and a good job of reporting. The reason why I'm not using Virginia data is because they don't report race of drivers at all, which defeats the main purpose of looking at this kind of information, since that is what people are generally interested in. They're looking at racial disparities. Or they're looking at whether the race of the driver and the race of the police officer making the arrest have some kind of interaction effect. In the case of Maryland, they refuse to report any kind of information about the police officer making the arrest, but that's a public policy decision made by them. What's interesting is that there's no rhyme or reason between the states that report this kind of information well and those that do not. You might expect that there's some kind of political correlation where a progressive state that's claims to be interested in transparency would do a good job of this. New England states do a horrible job about reporting these kinds of this kind of information, and Texas, for example, does quite well. So there's very little rhyme or reason there. A very common thing to do is to work with strings to try to normalize them in some way, capitalize them, or make them all lowercase. What you want to do is take a column name, type .str, and then hit tab to see what you need to do. And tab completion will do the rest. You'll see the list of methods that are available, and the .stir is just a very powerful tool. As is the .dt, which is for datetime methods. So in Pandas, you can do something like look at all the Fridays, or look at the entire week, or go ahead by 1 month. And both string and datetime operations are probably another 5% of why people use Pandas. It's still 80% because of pd.csv, read CSV. So here we just see the number of men versus women in this data set. Men get pulled over more frequently, it seems. Of course, what's the key data that we're missing if we want to know if there's any kind of anti-male discrimination? I mean, we don't know the purpose of the stop. We don't know the frequency at which men and women drive. If there are just more men on the road, then there's no discrimination against them. We also, the most important thing is we don't know actual driver behavior. And so that will become important when we look at a more fraught example using race. We don't actually know what drivers are doing. And so we can't just look at a number and see that the majority of people pulled over are a particular category and say that that constitutes discrimination on the part of police officers.
What about the car? Is there information about the type of car, the vehicle?
So in this data set, no. Later I give a list of further resources, and Montgomery County provides lists on all vehicle makes and models for cars that they pull over. It's really a department by department thing where they get pulled over or not, whether they report that information or not. So here I just want to point out that you can apply all sorts of functions to any kind of column. In this case, we want to take the mean of the subject age column. In general, this is going to skew younger for obvious reasons. I'm going to skip the part where you code with your laptops because this is going to be a sit and watch kind of lecture. But we see that if we search for the person with the smallest age, just by doing subject age.min, we end up with a 10-something-year-old boy. And if you look over to the reason for the stop and look up 16-101, you'll see that that's driving without a license. So I was wondering generally whether this was a data entry error, and if it was the case that this was like a DWI, I would have thought that this is just a matter of bad bookkeeping. The fact that it was driving without a license suggests that it really was a 10-year-old boy in, actually I'm not gonna say the county just in case anybody starts looking it up. We gotta keep those things private.
What's the oldest one?
Good question. So that's a good question, right? Like whether that's a real number or not. Let's see what they did. Whenever a motor vehicle was being driven, blah, blah, blah. So it looks like driving without headlights on. I mean, it doesn't give me any insight, right, into whether that's real or not. That could very well be real. Where are we? One thing you might want to do whenever exploring any kind of data set is just plot it out. And let's just talk briefly about what kind of visualization libraries you have available to you in Python. How many people here use matplotlib as their primary plotting? Okay. Actually, how many people use ggplot2? Interesting. Interesting. How many people use Seaborn? Okay. And I think for Altair, we saw like one hand. Just briefly, I want to talk about the advantages and disadvantages of using some of these different libraries. The advantage of matplotlib is that it's been around for 20-something years, and the syntax, or I think the API in general, is just based largely off of MATLAB because it came from a university environment, and there were lots of engineers who were used to the MATLAB commands, and then when their principal investigators got tired of paying the licensing fees for MATLAB, they switched to matplotlib and lived happily ever after. And that's the reason why the matplotlib library is used so extensively in academic journals. It's able to produce pretty pixel perfect representations of what you want. The disadvantage is that it's extremely verbose. You have to be very imperative about what you want and where you want it. The advantage is that it's very stable. And that you can really do anything you want with it. Seaborn is matplotlib, but pretty is all I can really say about it. The defaults are much better than they are in matplotlib. And you can be a little bit more declarative rather than imperative in how you structure your visualization. So here, I think it's pretty obvious what you see. It's just that the age skews young for people being pulled over. So I think it's time to take an aside and look at Altair, which is the other part of my piece, and to make the argument, so to speak, for why you should consider using it instead of matplotlib if you have the ability. So there is this idea that there is a grammar of graphics, and it's been discussed since the 1960s. There is an impenetrable French book on it. It's impenetrable both because it's in French and because France. It's more about the philosophy of graphics than it is about coding, of course. But the idea is that there are these basic building blocks of visualization. There's data, there's transformation, there's encoding, there's scale, and there are guides. And you as a visualizer, you as a programmer, should not be spending your time specifying how things should be done. You should just be specifying what should be done. You should say that X is this and Y is that. And then the grammar of graphics that's inherent in this program should be able to output something that is meaningful and interesting. So Altair is a relatively new library. I think developed largely by Jake Vanderplas at the University of Washington, but by other collaborators as well. And it works on something called the Vega and the Vega Lite library, which are JavaScript libraries. The key is that you will never be required to write JavaScript. How many people have worked with D3? Wow, a lot of people. Do you like D3? I mean, it's very pretty. It's hard, right? It's very hard. Mike Bostock at the New York Times is a very smart dude for developing it, but also you have to be a bit of a masochist to use it. So D3 is used by Altair eventually to render these graphics. If I run this cell, it's going to fail, and I will explain why it fails. One disadvantage of it is that what Altair does is create a JSON object of your visualization, and it stores it as part of the Jupyter Notebook. As a result, the Jupyter Notebook becomes very large if you have a large number of rows, and so there is a set maximum of 5,000 rows for any data frame. There are a few ways around that, and we'll talk about it in a second, but first, I just want to use a small ready-made data set to demonstrate how Altair looks, and so we'll use the cars example just to show off what the JSON representation looks like. A nice thing about this JSON representation is that it's human readable. So there are a few visualization libraries that produce JSON, but none of them could you debug if you looked at that intermediate output, whereas this is quite understandable. We're obligated by the gods of machine learning and data science to use the iris data set whenever we introduce any kind of new concept. I don't make the rules, I just follow them. And so this on cell 43 is the most rudimentary Altair graphic that there is. You are saying create a chart, select iris as the data set, and make the mark point as your, what's the word that I'm looking for, as your data mark encoding. And so these are all the rows in this data set, one on top of another. So it's meaningless, but that's where you start from. If you then say that the x-axis encodes the petal length, you get this. If you then add the y-axis, all of a sudden you have this scatter plot. And I would say this kind of declarative style is a lot more intuitive and just a lot more succinct than you would get with matplotlib. One fantastic thing about Altair, and a drawback about matplotlib that I forgot to mention, how easy is it to add interactivity of any kind to a matplotlib visualization? It's extremely, extremely difficult. Whereas this, because it is ultimately rendered as JavaScript, obviously interactivity is part of the package. So here, all we have is this box selector. Now, right now it doesn't do anything, but all it took to do that is this one line here, interval.selection interval, and adding this one property here. And even this, though it doesn't do anything, would have taken you quite a lot of effort in matplotlib or Seaborn, to be fair. So how did we get the two charts to appear next to each other? It's this logical OR operator, which I don't think he means to be a logical OR operator. I think he just means for it to look like a figure that means two things are next to each other. Nothing has changed here. We still have this interval selector. All we have is just another chart where we've changed the x-axis. But now, if you select one, because the alt value is light gray, you see that only the colored part is selected. And if you move this, you see that the other side moves as well. And so you can imagine doing this with the cars example as well. If we have time, I'll show that, where you can have, for example, cylinders and acceleration on one hand, and miles per gallon and displacement on another. And I'll show one example using our data set here. I just wanted to go with something simple at first. So I would say that this is very impressive because this is 10 lines of code to create, I think, quite a vibrant, interactive visualization, and one that you can save out to HTML, one that you can easily save in any other format, or just use Flask and stick this in there, and you're going to have a very interesting application very quickly. I mentioned earlier the 5,000 row maximum that, excuse me, that Altair has, and there are a few ways around that. So this right here, if you execute that command, instead of storing the JSON document inside of the Jupyter Notebook, it'll just be stored as a JSON file outside. It still creates a rather large JSON file. You'll still be slowed down for an 800,000 row data frame. It still might be difficult, but for anything that's not large adult son data, but just like medium-sized data, this is probably the way to go. Just have it store the JSON as a separate file, and then the visualization will read out that JSON file and create the graphic that you're looking at. The other alternative is, of course, to not use Altair to do your binning and your aggregation, to do things like counts, but to do the aggregation ahead of time using Pandas, to use your group by operations, the things that you're used to just reduce the dimensions of your data frame. And here, I'm skipping ahead to the group by operation, which we'll get to, but I just grouped it by police department, so that here all we have are police departments and then the average age of the person that they pull over, and what percentage of the time an arrest is made, what percentage of the time a search is conducted. And here, these are all the police departments. The only other thing I added here is if you just see the tooltip department name, and from then on, whenever you hover over something, you get the tooltip. The documentation on Altair is really excellent. And again, the lack of verbosity makes a big difference when you're trying to work fast and when you're trying to make a visualization happen quickly, because you're just trying to learn about the data set rather than try to create a finished product. Import. Oh yeah, import, that's right. Thank you.
Oh no, it should be from import.
All right, right from, that's right, yeah.
Close, yeah.
Yeah. Just wanted to point out that it does geographic mapping as well. This is new in Altair 2.0, which came out relatively recently. I did not attempt to get the shapefiles for Maryland counties, which would be an interesting personal project for any of you to do if you want to create a beautiful visualization of police stops using that kind of data. It's just hard to work with shapefiles when it's already not in a data set that's pre-made for you. Any questions on Altair so far? Questions at all? Comments about policing? Controversial comments about policing? Yeah?
Actually, I was curious how the race data was collected. Is it assumed, or is it?
So that's a very good question. It's kind of a deep question. It's whatever the officer puts down. So presumably he looks at the driver's license of the person that he's pulling over. There are some states that refuse to call people Hispanic. So Texas, whenever they pull people over, the Texas state troopers assign Hispanic about 5% of the time to the people that they pull over. And that is complete nonsense, obviously, given the population of Texas. There's an interesting solution to that. So what researchers do, if they're able to get the last names of the people pulled over, they look at them. Then they look at census data, and they see what percentage of people with that last name self-identify as white, Hispanic, African American. So you pull over Mr. Gonzalez, you look in the census records, you see that like 90% of people who have the last name Gonzalez self-identify as Hispanic. You declare that all Gonzalezes are Hispanic. You were obviously making some mistakes the other way, right? Like the former Miss Gonzalez is, well, a Japanese American woman marries Mr. Gonzalez and changes her last name. You were in trouble there, but it's better than nothing. So that is just to say there's all sorts of weird things that you have to do in order to get that data correct. This is a very good question. Yep.
On the completely other side of that question, what is the kind of difference between something like this and something like ggplot2? So like, is it, because I think ggplot2 is also a grammar of graphics.
To me, the biggest difference is you don't have to use R to use this. Which, I mean, like, it's not a knock against R. I think that the reason why so many people stick to R is because ggplot2 is so good. It's so intuitive. I think that's overwhelmingly the reason. I think the reason why people use Python is because Pandas is good enough, and then the rest of the ecosystem is so much more varied, and you have so many more machine learning tools. And plus, if you want to stick this into a web project, you have, of course, you have Shiny and R, but there's so much more in Python.
Is it okay if I
Yeah, absolutely.
So in terms of the syntax, you'll be building things by layers, and whenever you add on another element, use the plus sign as something that you may be familiar, like the pipe operator.
Yeah.
In Unix, it's the plus sign for ggplot, which is different from how you would use it in dplyr or other things. Just that's specific just for ggplot2.
Oh, cool.
So to get to the controversial stuff, finally. So these are the raw numbers of how many people are pulled over from the select police departments. One thing I noted earlier is that Baltimore City, which is obviously an important component of the state of Maryland, did not report racial categories. And that's overwhelmingly a large African-American city. So this data is, of course, skewed. One thing we might want to do is just to look at percents. And for that, I will try to type with two hands.
It's like I can hold the mic.
I'm good. So we see roughly half the people pulled over are white. Because we don't have good statewide numbers here, we don't want to use statewide census data either. But if we look at a particular county's department, we can look at census data from that county and compare the base numbers of the racial categories versus the number of people pulled over. So Baltimore County, people who are familiar with Maryland know that that's not the same thing as Baltimore City. Baltimore County is the collar county that surrounds Baltimore City, completely separate government, completely separate police departments. So.
Aren't you making the assumption though that they're getting pulled over in the
Yes. Yes,
Yeah.
absolutely. We are also making the assumption that the Baltimore County Police Department is only making stops in Baltimore County and not just over the border. And also, we are not splitting up Maryland State Police into the place where they made their stop. All those things you could do. The problem is that this data set does not have good geolocations. It has intersections. And so if you want to spend the time, which I think is quite viable if you were going to do it as a serious academic project and turn those intersections into geolocated data, then you would do that. So here we see in Baltimore County, about half the people pulled over African American, while only about 31% of the, this is for Montgomery County. So here for Montgomery County, the Montgomery County census has African Americans as 20% of the population versus 31% of the police stops are of African Americans. Still, this is not evidence of discrimination. It's just evidence that African Americans are pulled over more frequently. There are some things that we can do, and we'll quickly talk about them, to discover whether there is actual bias. One issue we can look at is outcomes. So someone is pulled over and they are searched, and either contraband is found or contraband is not found. Either an arrest is made or an arrest is not made. If you have one category of people who are searched and 80% of the time something is found and an arrest is made, that suggests that the threshold for pulling them over and searching them is quite high. It means that the police officer has just a high degree of confidence that something is wrong with this vehicle, with this person, I'm going to find something. You have another group of people where at whatever rate they're pulled over, if when they are searched, the police officer only finds something 5% of the time, it suggests that the threshold for searching them is much lower, right? It suggests that the threshold for pulling them over is much lower. And that can be evidence of bias and discrimination, even if we don't find it in just the pure number of stops. A secondary interesting way of doing things is that we have some date times here. In particular, we have time of day, and it gets dark at different times of the year. So some set of researchers have proposed something called the veil of darkness test. And the veil of darkness test just looks at the idea of, are African Americans pulled over less frequently when it's dark, in the inter-twilight hours, with the presumption that the police officer has a much harder time identifying the race of the driver during that time period. But because it turns dark at different times of the year, you can account for things like changes in driving behavior, changes in the commute pattern. So you can look at the same commute pattern and decide whether, and determine whether African Americans are getting pulled over more frequently. So to spoil the surprise for the entire nationwide sample rather than for Maryland, it turns out that for Hispanic Americans, the veil of darkness test shows that there's a large amount of discrimination against Hispanic drivers and a modest amount against African American drivers. I think the veil of darkness test is controversial, but it's interesting, and it's one of the best tools that we have. It's hard to come up with something better. Since we're going to be looking at different categories here, particularly subject race, we have to talk about the group by function. So anyone who uses SQL, I think, is familiar with these kinds of this kind of functionality where you do a split on a particular category, then you apply a particular function to it, and then you combine. In Pandas, that would be with the group by operator. And so here we have the Montgomery County Police Department. We group by subject race. We look at whether a search has been conducted, and then we look at the percent of the time that that's true. So the first thing that jumps out is that in the overwhelming number of cases, there's no search conducted, just because it's a regular police stop. It's a citation for a speeding ticket. But we do see that African Americans in Montgomery County are searched about 6.5% of the time versus 4.3% of the time for white drivers. For better or for worse, Asian drivers in virtually every county and municipality in the United States are never pulled over. It is like 3% is the highest that you will see for searches, at least. I want to hear any other questions about like Pandas syntax or Pandas ideas or this data set. Yeah.
When did Pandas come around?
So I know where Pandas came from. I don't recall the exact date. Pandas came from a hedge fund in Connecticut. And it actually stands for something. I think it stands for Panel Data Analysis, Panel Data Series. And so it was used primarily for financial data. Does anyone know the year that it came out? I figure mid to late aughts. Yeah, I'll Google it later.
You can look it up. Wes McKinney quit his job to work on it full time.
I think that's true.
Yeah.
I think he's doing something else now, like opening up the Pandas ecosystem more widely.
Yeah, he's working on Apache Arrow, a new data structure to underlie data frames.
I think that's right.
January 2008.
That's when, oh, okay. Huh.
First initial release.
So this is Maryland-wide for the data set that we have available. We see African Americans are searched more frequently than white people are. And here, we're going to look at the actual outcome test. So the outcome test was proposed by Gary Becker, who is an economist at the University of Chicago. In fact, a conservative economist who nevertheless argued that if you see situations where you have this disparity in the amount of times that the police is successful in a search, that can be evidence of bias. Yep.
Or could it be evidence of planting? You said it's found or not found, but planting.
That's right. So we have zero idea about malfeasance of police officers in any of these data sets. We have absolutely no idea. For that, got to go to body camera, to internal review, to some other method. This is completely reported by the police themselves.
They're not going to say it's planting.
Yeah.
Is there any work being done on video data?
You mean on accessing it? So, but like reviewing it through.
Like actually like processing on a camera, that person.
I think so there is, and the major issue there is that the PBA unions or the Fraternal Order of Police generally require that those tapes either be destroyed after a certain amount of period of time. So if there's an incident, you review the tape, but a kind of like machine learning search through this large corpus of video is not going to happen barring different kinds of collective bargaining agreements being struck with police unions.
There was a study done on the existence of body-worn cameras and what it does for arrests and different things like that in DC.
Right.
So they didn't actually analyze any
data, right.
But they surprisingly found it had no statistically significant effect. So I think it was done through the lab at DC. If anyone's interested in that.
Yeah, that does sound right. I think that those kinds of results happen across the country as well. So here we're just looking at the state of Maryland, and we're looking at the rates at which contraband is actually found. And if we look at the rate for Hispanics, it seems like less than 1% of the time it is. And here, so one problem with this data set is that we do not have good contraband data for every single police department. Some police departments just do not write down whether something was found. We do have good data on what is the final disposition in each particular case, whether nothing happened, whether there was an arrest, whether there was a citation, or whether there was a warning. And we see here that for African Americans, when a search is conducted, so this is a mask, it restricts the Maryland data frame to just the situations where a search is conducted. And then we're grouping by race, and then we're looking at the outcomes, and then we are looking at the value counts, the normalized percentage value counts. So in situations where a search is conducted, white motorists are arrested 54% of the time. African American motorists are only arrested 43% of the time. The counterintuitive conclusion there is that there is bias in search, because it seems that the threshold for searching an African American driver must be lower, if you are searching them and then you are not able to find enough evidence to actually arrest them, put them in cuffs. So of course, that means there are a couple of different ways of looking at the data. One can say, sort of naively, that this shows police officers acting with particular fairness, in the sense that they are arresting white people more frequently than they are African Americans once a search has been conducted. But perhaps that means their threshold for pulling over a white motorist is so much lower. So I suppose I want to talk a bit more about the issues with working these kinds of real-world data sets. One thing is that it is just important to have some level of substantive expertise, or to have someone you can turn to who has some level of substantive expertise when you're working with this stuff. Because you will not know what the exact difference is between a citation and a warning. You will not know the exact kinds of codes that are being used by police. It's very difficult to interpret this kind of data without some kind of subject matter expert at hand. The definition that Jake Vanderplas gives for what is a data scientist is controversial, because many people will say that structured data is structured data. And if you have statistical know-how, and if you have some hacking skills, and you put them together, then that is data science. And I do not take a position strongly one way or the other. I would just suggest that there's a lot to substantive expertise. The other issue I want to point out is that you're going to see all sorts of garbage in public data, unless you're just looking at Kaggle, which has done all the work for you. So for example, for dates, one of the most frequent dates you will see in any kind of time series is January 1st, 1970. Like 60% of the dates will be January 1st, 1970. And someone's going to tell me why. Yes? So that's Unix epoch time. I have seen states use December 31st, 1969, like 1 second before epoch time, as the null value. Please don't do that ever. But you're going to have to deal with that if you're going to be looking at this data. Finally, I just want to talk about some resources that you might be interested in. Jake Vanderplas's book, the Python Data Science Handbook, is probably the best resource to learn how to use pandas in this space, and it's available online for free as a GitHub repository. It's a series of notebooks. If you want to learn more about the local situation, the Montgomery County has an excellent series of data sets, including, I think there was a question about whether makes and models of cars were available, and they are available for Montgomery County. So you can see whether beaters are pulled over more frequently. I think they are. Like, the older the vehicle is, the overwhelmingly the more likely it is to be pulled over. I think they keep track of colors as well, so you can see if red hurts you. It generally does.
What about vehicle condition?
I don't know if vehicle condition is ever recorded on, I guess what do you say, fair mint on a police report? It's probably hard to catalog that. The Stanford Open Policing Project has, I believe they have not actually published anything. They have a working paper in which they suggest this kind of veil of darkness test and this outcome test. But you can see the entire data set, and you can look at the states that are available. I think Virginia is still not available. And of course, when you want to get started with pandas, my strong recommendation is, for the first time, just download a Kaggle data set that's been cleaned for you and try out all of these commands yourself. With that, I think I just want to take questions if there's some more. Yeah.
Just on the data set, which state has like the cleanest data that you found?
Vermont has very clean data. It's also very easy to work with because Vermont is tiny, and so yeah, everything will fit. And Massachusetts is very interesting to work with because you will find ridiculous disparities, which you might not expect if you just are going on a Massachusetts is a liberal democratic state, and therefore everything is fine and perfect there. Yep.
We find in most states they're centralizing
based on different types of police forces, or is it kind of a manual law? Like DC, I think we have like 27 or something different police forces.
There are 27 police forces in DC.
Like Capitol Police and Parks
Yeah.
Police and then all that.
I mean, I'm guessing in DC, just because of the federal government, you end up with so many more agencies. Police is, of course, incredibly local in the United States. So you have county sheriffs, and you even have town constables, and you have village constables. On the whole, states do a good job of reporting what their state highway patrol does. And they do a poor job of figuring out what various city governments do. Yep.
Ask a very beginner question.
Yeah.
Section 2.
Section-
Import data.
Section 2, import data. Yes, sir.
I have not actually looked at the CSV in its entirety.
Yep.
I take it that's a subset of the columns that are available.
I see. So everything gets imported when you do pd.read_csv unless you specifically select columns to be imported. In this case, we are not selecting specific columns. We are picking particular columns to which we will manually assign a data type rather than on relying on pandas to infer the data type for us. And so if we did not do the dtype argument here, this would absolutely work fine. The only difference is that it would take a little bit longer because it has to go through the entire column until it can infer a data type, because it might be a bool, 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 but at the very end there's an integer and now it becomes an object. Secondly, it'll take more memory if you're not explicitly listing the data type. And third, you might have to convert manually later down the line if you want to do string operations or if you want to do some kind of aggregation function on them.
Was this data further
Sorry.
sorry.
No, go ahead. I'm sorry.
Yeah.
Was this data further upstream, like the age? Did it take like a birthday and then?
It did.
subtract
It did. And you had a question?
Just,
Again.
again, another beginner question.
Yeah.
The category data type, which refers to, is that like a string or is that something?
So the category data type is its own kind of data type. It's any kind of situation where you have a discrete number of values that you want to capture. So you either have male or female in the case of this data set. In the future, there will be more categories, but here it's male and female. For race, there's just 5 or 6 possible options. If it was a huge number of options, you would just leave it as an object, as a string.
Just kind of a follow-up on that. Are there ways to target specific data types? Like in R, you could say like strings as factors equals false or true. Are there specific ways to do that with your, other than just writing them all out and assign them individually?
Yes, and I don't remember the commands for that. Yeah.
Is there an easy way to sample data when it comes to visualization? Because
There is. I think there's just a dot sample. Does anyone know off the top of their head? I believe there's a dot sample. Could try it out offline. Okay. I think we're going to have extra time to mingle, unless people have more questions.
Oh,
Yeah.
You never did an intro of yourself.
Oh yeah. So I'm Ilya. I do mostly political consulting work for Democratic campaigns. So they hire me to do opposition research, and some of that is Python related. A large number of it is not. I work mostly on state and local races, and mostly in the Northeast, in the tri-state area. And I also have a startup called Legislator, which collects state legislative voting records and provides the kind of information that GovTrack would for the federal government on votes conducted by state legislators. So if you want to see who voted for an abortion bill, who voted against an abortion bill, you would come there. Give it back to, yeah.
Okay, you mentioned a D3 as well. So was that the one that they used for the 2016 election on New York Times?
Absolutely.
Yeah.
That beautiful precinct map.
Yeah, 'cause
Yes.
I remember that was like the best.
Yeah. Well, it's because Mike Bostock works at the New York Times, so they have the inside line on all things D3. Bastards. All right.